So now that we've presented this idea of the prisoner's dilemma and this concept of game theory as a tool for solving these frequency dependent problems, and you're familiar now with the basic premise of the prisoner's dilemma. Now we are going to talk about some specific animal examples where we see reciprocity demonstrated, and then we'll extrapolate that then to human behaviors as well. And so, one of the species in which we find evidence of reciprocal altruism is vampire bats. And vampire bats share food. And of course, in this case, it's the situation where they're sharing blood. And so, vampire bat food sharing was first studied by Wilkinson in 1984. And just a few basic kind of ecological notes about vampire bats. They're active at night. Generally, they feed upon livestock. When they bite, they inject a little bit of anesthetic and an anticoagulant so that the blood flows more freely. And then when they've had enough, there's a coagulant that does then allow the blood to clot. And they roost then during daytime periods. And so they would feed at night, roost day, feed night, roost day, feed night, roost day. They will starve to death if they go 3 day periods without food. So 3 days of roosting. So that really can then only come out to 2 missed feeding attempts. Vampire bats are not generally successful every single night that they go out. So this likelihood of having a missed feeding bout or a failed feeding period is pretty high. The probability of not starving to death in a given year is 0 for juveniles. That means that there's no way that juveniles would survive a full year period if there was not this innovation of a behavior of food sharing. The probability of not starving to death for adults is only about 0.16. So most adults would also starve to death within a 1 year period. So how then do vampire bats solve this problem? They solve this problem by food sharing, just like human groups solve this problem by food sharing. And we'll move into, of course, our discussion of humans in just a few minutes. For vampire bats, the form that food sharing takes is the regurgitation of blood. So when they feed, they fill their bellies with blood. When they need to share food in order to help ensure survival, they'll regurgitate up a portion of the blood that they have in their stomachs. So the bats generally have 2 rules of thumb here for their food sharing behaviors. Reciprocators give to bats who are more in need, just like we see this asynchrony in abundance and need for humans and for food sharing or at least reciprocity to have evolved. We also see if we were just to flip this curve over, it would have the same shape as the diminishing returns curve. And so this time to starvation curve shows that the time to starvation along the x-axis, the percent of pre-fed body weight along the y-axis. And so what this means is that individuals who are early in the curve, because it's the inverse of the diminishing returns curve, individuals who are early in the curve have recently fed. They've got a long period of time until starvation. They're able to give up a small proportion of their body weight. So if they've recently fed, they're at about 110% of their pre-fed weight to about 100% of their pre-fed weight. Therefore, by giving up 5% of their weight in blood, what we see here along this axis, so we're going from about 97% of pre-fed weight to 92% of pre-fed weight, they are only losing here what the equivalent of this amount. So they're not even losing 10 hours of this time until starvation. If, by contrast, they've had failed feeding attempts and they're only at about 80% of their pre-fed weight, that puts them out here on this curve at G. They would be only about 11 hours until starvation. They gain 5% of their body weight. They go from 80% of pre-fed weight to 85% of pre-fed weight. They gain 19 hours of survival. So it brings them from dying during that roosting period here with only 11 hours left until they're going to starve to death, to having about 30 hours left until they starve to death. So they're able to then weather that last roosting period and try to go out and be successful then that very next nighttime feeding period. So we have an asynchrony in abundance and need. Some bats are going to be at 110, 120% of their pre-fed body weight. Some bats are going to be down here at 80% of their pre-fed body weight, or perhaps even lower. These are going to be the bats that have a great need and that are going to gain a much greater value here from that increase in body weight. The value that recently fed bats are giving up is very, very small, only about 5 hours of their lifetime, basically 5 hours of additional survival time. So individuals who have recently fed give up less survivorship than they will gain when they are shared with, because bats have these unequal kinds of returns, these return rates that have a high degree of variance. So bats are constantly changing positions along this curve to where sometimes they're in need, sometimes they are not. So a little bit about vampire bat socioecology. The vampire bats are generally centered around female groupings. Those groups of adult females consist partly of kin, but the overall degree of relatedness is only about zero point 0.1. So that means they're related at less than the cousin level. There are going to be some bats, of course, who are uh, who are more closely related, mothers and offspring, sisters, etc. There are also going to be some bats in this grouping then that are unrelated to each other. Females will associate closely over long periods of time, often for more than 2 years, sometimes even more than 11 years. They have about a 30 to 33 year lifespan. So um, if we're in this situation where we are going to have upwards of 11 years of close association. If you break down even 1 year into these overlapping periods of 3 days, these overlapping periods that would be starvation periods, you've got many, many, many opportunities for reciprocation. So, they're not sharing on like a seasonal level. I mean, we're talking about food sharing on this day-to-day basis. And so, um, the fact that they will associate together for long periods of time, I mean, even over a 2 year period, you're going to have thousands of possible 3 day combinations of periods of need. And so then there are two big predictors of the degree to which one bat will regurgitate blood to another. The first is kinship. Okay, there is basically the more closely related that you are, the more likely you are willing to regurgitate blood. So we'll see a strong degree of regurgitation among full siblings, full sisters, among mothers to offspring. This is one of the things that guarantees that then these juveniles who would otherwise starve to death, 100% of them would starve to death in a given year. The sharing between these um, mothers and offspring, or grandmothers and offspring, or older siblings and offspring, are one of the ways in which these juveniles stay alive. So we have this independent effect of kinship. We then also have an equally strong um, degree or likelihood of sharing among people that or among people, sorry, among bats that associate with each other for a very long period of time. So this degree of association between two bats is as strong as of a predictor as the degree of relatedness between two bats. You don't share with bats with whom you spend 60% of your roosting periods, or less than 60% of your roosting periods together. So, these animals can migrate between groups, and you run this risk when you migrate into a new group that nobody's going to share with you because you have yet to form this long degree of association, this long period of time in which you've been roosting together. you have yet to form this long period of association, this kind of long-term pattern of roosting together. Um, so we can look at the data and see, kind of stratify it and share this likelihood of sharing based on relatedness, independent of this likelihood of sharing based on kinship. And so regurgitators, when graphed by this degree of association, we find that there's no likelihood of regurgitation if you roost together for fewer than zero point 0.6 of all nights or 60% of all nights. At 70% of all nights, 80% of all nights, there's a very strong likelihood that individuals will regurgitate with you. When we look at all possible donors, though, we notice that some individuals who don't associate with one another do actually share food. And so this is where that second rule of thumb, based on the degree of relatedness, comes in. That it is very likely that you will share blood with individuals who are related to you at the full sibling or parent offspring level, that is this zero point 0.5 degree of relatedness. It is also very likely that you will share food with individuals who are related to you at the 0.25 level. So this is half siblings, this is grandparents to grand offspring, etc. And so when we stratify based on relatedness, we find some related, some unrelated regurgitators. These, of course, are the individuals who then are in close association. So we've basically got two rules of thumb. We've got this rule, this first rule of thumb that's based on kin selection that says if you are closely related to another individual, then share with them. We've also got this additional rule of thumb that's based more on what we might, among humans, call friendships. That if you spend quite a bit of time together, more than 60% of all roosting periods, then share. We find similar kinds of reciprocal relationships even among grazing animals. And so here we're looking at impala, um, and we're looking at grooming relationships. And so we've got impala males and then we've got impala females. And that line of identity, meaning that you get one bout for you give one bout for every bout that you receive, is what that linear relationship represents. It's what that line represents. That basically, for every time that someone is willing to groom you, you then groom someone else. And so for impalas, which don't have necessarily this large degree of a social brain, I mean, they are a social species, yes, but their degree of sociality is much more, uh, let's say, not socially savvy. They group together because they don't have very much feeding competition. They group together for the anti-predator benefits. There's still this kind of emergence of tit for tat reciprocity for as it's related to their grooming bouts. And what's the benefit of grooming? Well, predominantly it's the removal of ectoparasites, which is really important for overall health and immunity. So we've got an abundance of primate examples of reciprocal altruism as well. A number of researchers, including Craig Packer, Gene Altman, etc., have studied baboon alliance formation. Now, baboons, particularly males, will use alliances for kind of two avenues. One of those is helping each other kind of through rank acquisition or helping each other among bouts of aggression. And so, what we see here among baboons is that males have to fight their way into a troop at puberty. And so, males will have this period where rank kind of trumps all, and they really have to achieve high rank to be able to be a part of any group. And so that it's easier to acquire high rank if you've got support in your quest for high rank. And so we see alliance formation in the scope of rank acquisition, that baboon males will ally with one another to either hold on to high rank or to fight their way into a troop. Males also use these alliances to help each other get copulations. And so, in general, among baboon troops, the highest ranking male is able to kind of mate with whomever he wants by mere fact of his high rank. But if this were the case that the high-ranking male was the only male that was able to mate, then what would be the gain for any other male to stay in the troop? Baboon males will stay in the troop they move into as adults for a pretty long period of time, and they'll still be able to get copulations over that long period of time. And the way that they do it is through this alliance formation. So males will band together so that one or two of the males are distracting the adult male, the highest ranking alpha male, um, through perhaps kind of aggressive behaviors or just kind of annoying him, basically, like not leaving him alone and giving him a moment's peace. And so then when the highest ranking male is distracted by these other males who are kind of harassing him, the male who's interested in mating with a particular female is able to kind of sneak off and copulate with her without the highest ranking male knowing. And so these males will take turns basically in aiding each other in gaining copulations. One of the ways that baboons reinforce these social bonds and band together is through grooming each other. And so grooming is kind of the glue that holds your group together. And it really doesn't matter whether it's non-human primates or whether it's even humans. I mean, humans have very complex grooming relationships as well. Think about um, young girls, like teenage or early teen girls. What do they often bond over? It's through braiding each other's hair or fixing each other's hair. As they get ready for dances and such. It's kind of styling and putting on makeup and things like that. So even among humans, we find this kind of reinforcing of social bonds through grooming behavior. If you're in a romantic relationship, if you're quote unquote cuddling, you might like it if someone strokes your hair. These all kind of elicit a very visceral, very kind of primal response or instinct, even among adult humans who are engaging in this kind of grooming like behavior. It's not as important in a modern context that we have removal of ectoparasites, but even among hunter-gatherers, that removal of ectoparasites would be a big deal. Think about tick removal. There are a lot of diseases that are tick-borne. Think about care during outbreaks of head lice, etc. So, our grooming behaviors have their root in something that's good for health, but we've also then co-opted them into something that really just reinforces these close social bonds. Seyfarth and Cheney studied these alliance events or these alliance formation among vervet monkeys. And what they found was that vervets who have recently groomed, particularly among non-kin, or have recently been groomed, are more likely to respond to distress calls. For kin, it doesn't matter whether you've groomed recently or not. So if a vervet monkey gives an alarm call, and you're tracking who comes to their aid, kin will always respond. Just the fact of being kin is enough. Non-kin, though, will respond much at a much higher rate after a recent grooming bout than if they've not recently had a grooming bout. And so here, for kin, it's just enough to be kin. For non-kin, it matters whether you've engaged in some kind of reciprocal relationship. So, one of the things that's highlighted here with the baboons, with vervet monkeys, is that we don't always need to repay in the same currency. So here with the vervet monkeys, we've got a grooming relationship, and then we've got alliance aid in terms of supporting after an alarm call. And so just keep this in the back of your mind that this method of repayment doesn't always have to be in the same currency, and we'll talk in much more detail about what that means. Um, Franz de Waal and Craig Stanford have studied hunting behavior among chimpanzees, and so the monkey pictured here on the left is a vervet or a red colobus monkey. This is one of the primary prey items of chimpanzee males. They engage in cooperative hunting of red colobus monkeys, and what they do here is they each take a particular role in the hunt. So one male may sneak up unseen, so that he'll then be able to kind of flush out the monkeys into the arms of waiting males. Other males will climb trees in a very visible way, so that um, they're able to cut off these escape routes, so that the primates know, that the red colobus monkeys know, there's no way they can escape in particular directions. And then there'll be the male who does the killing strike. After the monkey is killed, there's a food sharing bout. And so males share firstly with other males who took part in the hunt. Secondly, they share with other males who are allies or friends with them, even if they didn't take part in the hunt. And then thirdly, they share with females, oftentimes who are demonstrating sexual swelling, so demonstrating this degree of estrus. Of course, chimpanzees kind of lie with their sexual swellings. They don't only swell when they're receptive, they swell at other points as well, as kind of like a false advertisement. So um, we see complex rules of food sharing here based on alliance formation, based on reciprocity. Why would males share with females? Well, it generally gains them access to copulation. So there's a net kind of fitness benefit, even if what they're gaining is not in the same currency. Males will also ally with one another to acquire higher rank, and so these quests for status. I mean, your position in the status hierarchy is tenuous at best, and you constantly face the possibility of being usurped. And so you form alliance partners for kind of territorial disputes and for rank acquisition. And then lastly, among non-human animals, we can look at cetaceans. These are the toothed whales, in particular dolphins, porpoises, orcas, etc. There are historical and recent anecdotes of dolphins aiding drowning humans. And it's a behavior that's based off of behaviors that dolphins already do with other dolphins. And so dolphins have three behaviors that they'll perform with other dolphins. One of those is called standing by. When there's a dolphin that's injured or facing some kind of danger, standing by is when the animal stays with the other animal that's in distress but doesn't offer any obvious aid. There's also assisting, where they'll approach an injured animal and swim between perhaps captor and prey. They've also been known to attack vessels and to push injured animals away from their captors. And then the third kind of behavior is, really the one that's the most intensive. This is what we call supporting. This is where one or more dolphins will maintain a distressed animal at the surface of the water. Why is this so important? Well, of course, dolphins are mammals, which means they breathe what? Right, they breathe air. So in this case, where they're not able to get themselves to the surface, they're going to suffocate if they don't have other animals that are able to help support them. And so the reason I said this is the most intensive is that they may engage in this behavior for the entire convalescent period. So if that particular dolphin needs 2 weeks to recover from their injuries, they may offer that physical support for 2 weeks or more. So this can be kind of a really long-term time investment. Why would dolphins support each other like that? Why would dolphins engage in this kind of behavior? Well, it's because there's this dolphins have long lifespans. Dolphins will survive for upwards of 80 years, perhaps even longer, depending on hunting pressures, predators, etc., human kind of intervention, predominantly. And so, um, with this really long lifespan, dolphins, of course, are also incredibly smart. They have a higher what's called encephalization quotient than even humans. That means the size of the forebrain, the neocortex, relative to the rest of the brain. So, arguably, dolphins are smarter than people. And of course, Douglas Adams co opted this and had the dolphins leave Earth during the time that the Earth was going to be destroyed with the note, "So long and thanks for all the fish." So yeah, there's a little bit of my geekdom showing through. Dolphins, though, because they have such ingrained behaviors of reciprocity with their own species, they will also extend this behavior to other dolphin and whale species. So they've got complex social relationships that we are only beginning to untangle that extend beyond the species level, and they'll band together kind of in solidarity with any toothed whale that may need help in the ocean. So we've got a lot of work that still needs to be done with marine mammals, and part of the problem, of course, with studying marine mammals is that they're marine. They can hold their breath a lot longer than we can. They travel vast distances, hundreds to thousands of miles, in their seasonal migrations, their quest for food, etc. They communicate over long distances. They're able to communicate in tones that we can't even hear. So they're able to use incredibly low tones and incredibly high pitches that aren't within our range of hearing. And of course, we have not yet puzzled out what their language means. So we're not even able to understand the messages that they are transmitting over vast distances. So it's very likely, as we understand more and more of dolphin behavior, that we're going to find more and more cases of cooperation, of reciprocity. I mean, we already talked about this hunting behavior that dolphins have of blowing bubble nets, working together and thereby increasing everybody's foraging return rates. So, dolphins are amazing creatures that unfortunately will probably drive to extinction before we really get to appreciate all the things that they are capable of.